In order to balance nuclear equations, we must understand the particles that are involved. Protons, neutrons, electrons, positrons, and alpha particles. The type of energy sometimes accompanies nuclear decay. This is called gamma radiation. You can see by the values in front of the particle the mass and the charge. So a proton has a mass of 1 and a charge of +1. A neutron has a mass of 1 and 0 charge. An electron, essentially 0 mass or very small mass compared to the neutron and proton, so relatively speaking it's 1. And -1 is the charge. And a positron has also very little mass and a charge of +1. The alpha particle is a helium atom, a helium nucleus stripped of its, the atom stripped of its electrons. We remember from first semester Gen Chem, this symbol X represents the element, A represents the mass number, which is the sum of the protons and the neutrons, and Z represents the atomic number, which is the number of protons. In nuclear particles, Z is the charge. The sum of the protons and neutrons in a nuclear equation must be the same on both sides of the reaction arrow. The same is true with the atomic number, or Z. If we look at the first equation, we have molybdenum 97. It's important to indicate the mass number because this is one isotope of molybdenum. Just as a refresher, most elements have multiple isotopes, most but not all. Molybdenum, in fact, has 7 naturally occurring isotopes. So we are dealing with the isotope that has a mass number of 97. Remember that the mass number represents the neutrons and protons. The atomic number is just the number of protons. So different isotopes have different numbers of neutrons, but they all have the same number of protons. So a different isotope of molybdenum still has an atomic number of 42. Here we are bombarding molybdenum with deuterium to make technetium 97 and 2 neutrons. Notice that the sum of the mass numbers is 99 on the reactant side, and the sum of the mass numbers is the same, is also 99 on the product side. And I say 99 because we have 2 neutrons, each with a mass number of 1. So this is 2 plus 97 is 99. If we sum the charges, 42 plus 1 is 43. 43 plus twice 0 is also 43. I'll let you take your time. You can pause the video to examine the second equation. 125 plus 0 is 125. 53 plus -1 is 52. In the third equation, 208 plus 4 is 212. And 82 plus 2 is 84. Let's practice. Here we are instructed to complete the equation. We have aluminum 27 being bombarded by a helium nucleus to form a nuclide, an unknown nuclide that we need to identify, and a neutron particle. Let's assume for a moment that for this equation, the third equation, we were not given the nuclide. Let's assume for a moment that we were not given a nuclide as a product for the third equation. Since the reactant is 212 for the mass number, and we were given helium is 4. You could set up, if you didn't immediately see that the mass number must be 208 for this nuclide if it were not given, you could set up an equation x plus 4 equals 212 and then solve for 208. On the next slide, you're going to have an opportunity for practice. Please pause the video so that you give yourself an opportunity for practice before the answer shows. So go ahead and pause the video, solve these two problems, the first two and the second one, and then continue the video to be sure that you have that your answer agrees with mine. Bye for now.